Hi everyone, Dmitry Mrzhansky is here, and today we're going to talk about solid design principles in context of Angular. This video was inspired by this comment, and I found this topic really interesting because I remember myself many years ago. I remember I knew all those 5 principles, but when it came to real life code, the real implementation, I could not recognize them in the source code. I could not apply them. And I decided that maybe not only I had such an issue, so I decided to make this video for you and explain it a little bit and show you real life cases. So this video will be split into 5 sections. Timecodes will be in the video description. Check this out and we're getting started. But before we start diving into those 5 design principles, let's talk a little bit what is design principle itself. And design principle, this is recommendations how to design your code such a way in order to keep it maintainable, flexible, and so on and so forth. And telling that it's recommendation, it means that it is very abstract. It doesn't have any concrete implementations. You can implement some design principle many different ways. And already on top of this design principle, we have design patterns, which solve some already concrete use case and implement 1, 2, or more design principles. And we are not restricted by only those 5 design principles. We have many more, like dry, don't repeat yourself principle, or KISS, keep it simple. And there are many of them, but those 5 are most popular ones, and we will have a look at them right now. And the first one I'm going to start with is the single responsibility principle, which sounds like there should never be more than one reason for a class to change, which means that some component or class or model should do only one thing, but do it well. So let's have a look at the application I prepared for you. This is just a simple widget, weather widget, which just exports some JSON data. And now let's have a look at the implementation of this. By the way, I have in this project 5 branches, every branch reserved for some certain design principles, so you can clone this project to your local machine and switch between branches and see implementation of every design principle. Okay? But yeah, let's get back to our implementation. You can see that my app component, which is only one component for now, we have the material toolbar, we have the main tag, which should contain the whole content for my web page, and also I have the widget template, and besides this I also have on export JSON function, which does export of weather widget data in JSON format. And I have some styles, yeah, but I collapsed it for now. Okay, this piece of code violates pretty much everything, not only single responsibility principle. However, we focus only single responsibility principle here, and yeah, let's figure out how we split responsibility between components. Actually, it sounds easier than it is, because very often it is hard to decide where ends responsibility for class A and starts the responsibility for component or class B. However, I have one rule which I use in order to determine if my class does too much or not. This is end word rule. And it means that you describe the responsibility of some certain component, and once you encounter the word end, it might be the signal that your component does already too much. Let's apply this rule to this example, and how I would describe the responsibility of app root component. I would say that responsibility of this component is to render the skeleton for my page. So it's top level components like toolbar and content. And we have already toolbar. We have this main content, and we render also the widget layout, and we do export JSON file, JSON data for this component as well within one single component. So it already gives us a hint that this component does too much. And what would be the solution for this case? I would suggest that widget should be definitely the separate component, and the logic here might belong to the component itself. So the solution would be to generate additional component. I will call it like a widget. Then I say that it has SCSS, it should have inline styles, inline template, and we skip tests, and we also do it flat. So I don't want to have the separate folder for this component. And I click run, and we have to get the new widget component. Here we go. Good. And now I can refactor it like this. So I can copy this everything, including this section, and we can paste it to the template of widget component. Here we go. Also, I move this on export JSON handler. Here we go. And also I have to copy styles. So I will copy this part, header, widget icon, basically everything except the content. So it will move to styles here. Go back, and instead of widget, oops, I forgot it here. And instead of widget, we just say that it should be app widget. Here we go. So if we go back, check it here, everything looks good, and hopefully our application should work as well. What's wrong here? Okay. I have to place it host here because we apply these styles to our host element. Good. Now it should be compiled successfully, and you can see nothing has been changed, but our app component became more lean, and it is responsible exactly for rendering the content and rendering the toolbar. But still, if we have a look at the widget component, we can say that, all right, widget component, it generates the layout, the view of our component, and it exports the data as a JSON. And most probably there export of the JSON is not, this logic, I mean, is not responsibility of the component itself. Yeah, it can handle this on export JSON click event. However, the logic is not the responsibility of this component. So I would suggest you to create the separate service, and this service we could call JSON exporter. All right, so let's run it. And yeah, we see that we created JSON exporter service. So we can move this logic from here and create some methods like export. Yeah, here we go. So yeah, and here I would inject our JSON exporter like this, and now I can call the export method against this JSON exporter, sorry, and I can save it. I should save it here as well, and we can go back and click export as a JSON, and it doesn't do its job. What is wrong? Sorry, actually it does. It, for whatever reason, jumps. All right, I have to fix it. All right, now it's better. Just if you're curious, it's Command Option minus on or plus on macOS, and you zoom in or zoom out this view. All right, never mind. But still, you can see that our widget is working, but we have split responsibility between three entities: app component, widget component, and also service. But one recommendation though, find your balance in splitting of these responsibilities, because you may split it to such a small pieces that, yeah, you will be flexible like a hell, but it might be too hard to support this. So find your balance. Usually you find it within your team during the code reviews, and yeah, it might vary from team to team what responsibility of what, because there is no some super strict rule which can determine that here responsibility of this component ends and starts the responsibility of another one. And this is everything about single responsibility. Let's move forward. And the next one is open-closed principle. So open-closed principle, very important one, and it sounds like software entities should be open for extension but closed for modification. And what does it mean in the real life? It means that you should design your classes, modules, and libraries such a way that you should extend its functionality without touching this component. It is a very good example, libraries. You cannot modify components which are coming from some certain library, yeah, because they closed, they are published into the NPM. You have no access to the source code to change. But still, you have to be able somehow extend this functionality. And here I prepared another example. It is very similar to what we see for single responsibility, but now we have two widgets, but different content inside. So the first one is weather, but when the second one is it's by mistake also weather, but it is the velocity, which shows the last velocity of your last sprint. And this is how I implemented this. It has small differences comparing to the first implementation, but this is like pretty much similar. We have the app separately app widget, and it has the property weather or velocity. And if we have a look at the component implementation itself, we will see that it has such a thing like ngIf. If it widget is weather, then we render the view for weather, otherwise we render the velocity view. You can of course use ngSwitch here, it doesn't really matter for this particular case, but you understand the idea. So the problem with this that it is closed, definitely, especially if we distribute this via library. It is closed, you cannot modify it, but it is not open. You cannot add the new content to it. As example, I want to have third widget which renders, I don't know, just a paragraph or another view, and I cannot do this because I restricted by only these two types, either it weather or velocity, and this is the violation of open-close principle. How we can solve this issue? Well, we can create separate view or separate component for every of this widget, and then we would use just a content projection like ng content. So I would suggest you to generate two components. First one I will name weather content, and then it will be SCSS, it will be flat inline. By the way, you can configure this everything inside the Angular JSON file, but I am too lazy to do it. I think it is enough, so we can run it. Here we go, and then we create the same but for velocity. Oops. Here we go, I can close it, I can close, I believe, this part, and now let's move this class, or this HTML from weather to weather content, right here. Here we go, and then we will do similar to for our velocity. This part, and copy it here. Then we have to adjust this part. We have to remove this everything, and instead we will use ng content. Right? So here, instead of ng content, will be rendered anything we put between app widget tag. You will see this in action, and there are another way how to implement it. You can use this with the component outlet and ng container, but it doesn't really matter for this case. You are free to implement as you want. Yeah, and I save it, and I have to probably add some styles, yeah, because the definitely value and widget icon should be part of styles for these guys. So I will create a new file. I will say it widget content SCSS. So here will be common styles for this everything, and weather widget it is here we go. This is this container. Let's rename it to the widget content. Here we go, and for weather we also rename it, and now we have to copy this part as well, and we copy it here, and as we renamed it widget content, it should be. Good, and yeah, I forgot that style URLs should be here, and let's import the widget content as CSS. Here we go, and the same we will do for this part as well. So I save it, and inside app component already, I don't need these inputs anymore. And I can define between those app widget tags, I can define which content I want to have here. And in my case, this is the app weather content. And in the second case, I want to have app velocity content. And now see the benefit of this everything. If I want to introduce the new widget and with some specific content there inside, I can easily do this. I can just place the paragraph there and say that content is coming. I don't know, whatever. And you can see that without modifying the app widget itself, I could extend it with another content. And now if you have a look at our widgets, you can see that I reused completely the widget itself, but content is customizable, and I can easily customize this and change the view. So this is the open-close design principle in action. All right, and the next one in the turn is Liskov, Barbara Liskov substitution principle. And it sounds like functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. Yeah, it sounds a little bit complicated. However, everything boils down to next thing. Imagine you have two classes, parent class, child class, which extends the parent one. And Liskov substitution principle means that objects of this superclass or parent class should be replaceable with its subclasses or child class without breaking the application. Let's have a look at the example. So here's pretty much similar where we stopped, except I fixed the issue with titles for our widgets, yeah, and this is pretty much it. There you can see the content for our widgets, widget content CSS, and yeah, things like that. However, let's imagine that we want to have slightly different wrappers. Yeah, we want to have this one, and maybe we are planning to have some another modifications of this widget container. And we know that all those containers will have some functionality like export to JSON, and all of them should support the input title. And we don't want to duplicate this everything here. We want to extract this to the, I don't know, some base class. So let's create this. Have a class, and I will name it like widget base, I will call it. And let's generate one. So inside this widget base class, I will move the whole logic from here. So I will copy it and paste it right there. Then I have to import the input. Okay, class is using, yeah, this is, it means that we have to decorate this with directive as example. because since Ivy, you have to do it if you're going to use inputs as example and extend your another component with this new one. What we exactly going to do right now. So I do not the export, but extend. This is what happens when I typing and talking at the same time. So we successfully extended this, and how we can violate the Liskov substitution principle. We can violate this by overriding this method on export JSON, and as example, instead of exporting the export JSON, we throw some error, like I do not support it. All right, and this is the already violation because it changes the behavior of this on export JSON comparing to its parent. There's completely different logic, and if you replace the implementation of this widget base with widget content, you will break your application, which is actually the violation of Liskov substitution principle. So the solution to not violate this principle is to just remove it, and remove it completely if you don't do any additional logic for widget component, or if you do, you should not break the contract of this. It should not return some completely different type which is not compatible. So if here return type is void, let's say, then also type of this handler should be also void. And you can of course call super, and then you can, I don't know, do something like console log additional, whatever. So this is how you can extend it without violating this design principle. All right, we are getting closer to the end, and the next one is interface segregation principle. And it sounds like many client-specific interfaces are better than one general purpose interface. And what does it mean? As example, we have velocity and weather content, and we would like to define some interface for them, some contract, yeah? And we usually do it via interfaces. So let's generate the interface. I will call it widget content and run it here. So here we go. And let's open this widget content, and as an interface, let's say I want to have the ID, which should be some string, maybe just for testing purpose, whatever. And let's assume that this content should support, let's say, live reloading. So means that we pulling some data from the server. If some new data arrives, we render the view. And we can say that we need the property loading, yeah, to show some maybe spinner during the request to the backend, which is Boolean. And we need some maybe function, let's say reload, and it should return void. All right, so we save it and we implement this interface for every content. So it implements widget content. Here we go. It already complains that we have to implement all necessary fields. So let's implement this interface. Here's the string. We can define some, I know, empty string as a default, and here we can say that it false, and reload throws some error, but let's say that console log do polling, right? So this is what will happen for this widget content. And We have to do the same for another one. So let's save it right here. And for weather, we're going to do absolutely the same. So I import widget content, and we also need to implement this thing here, empty, false, and do polling, whatever. So, and I see that I didn't save my app model. Okay, and now we are done, but here's the problem. Imagine that someone, I don't know, product owner comes to us and says that, you know what, the live reloading for weather makes sense because weather changes really fast and we need to reflect the latest data, but velocity, we update this data only, I don't know, every end of the sprint, usually 2 weeks, and we don't need to do polling for this data. It should not be supported. Yeah, it doesn't make sense for this kind of data, so it should not support the live reloading. But the thing is that we have to, okay, we don't support, we can leave it empty. But in this case, we still have to keep this loading property and reload just in order to follow the widget content interface. So this is where interface segregation can help us. So instead of having this, let's say, big interface, we have to split it on 2 interfaces. Let's say we can create interface reloadable, right? And we can move these 2 guys inside the reloadable interface. And then we would say that, okay, weather should support it, so we will implement also reloadable interface. Here we go. But here we do not support live reload, so we can safely remove this code which is not being used and which is obsolete for our velocity content, like this. And this is the interface segregation principle in action. So you just split one big interface to many other smaller interfaces. All right, finally, the last but not least design principle is dependency inversion principle. And it says that we should depend upon abstraction, no concretions. How does it look in the real life Angular application? You encounter this design principle every time when you use dependency injection. Let me show you some small example. Say we have the service, polling service, and you inject this service inside your constructor. And we have to call super because we extend widget base. All right. So once you inject this, you might think that you depend on concrete class, on the concrete service, which is polling service. But it just looks like this. In fact, Angular under the hood performs some magic and it creates such a thing called injector, which acts exactly like this abstraction layer. If you don't completely understand what I mean by that, I would recommend you check out my video about Angular dependency injection, and this video will make everything clear. But just to finish this example, what I mean that we don't depend on the polling service is that you know that we can use dependency providers like use class as example, and we can, I don't know, provide another polling like this, yeah, and I have to create some specific class, and And having this setup, we are not pointing to the polling service anymore, but rather to we're pointing to this another polling class. So despite we see the reference to some concrete implementation here, it doesn't mean that this concrete implementation will be used. But I'm going to remove it, and I will show you slightly another example for this everything. So actually we can create a lot of abstractions. We can create abstractions over abstractions and so on and so forth. Sometimes it is over engineering, sometimes it might be helpful. And let's imagine that in widget component inside our wrapper, we want to get reference to the component which supports the live reloading and trigger this reload method. So how I could do it? I would call content child, and I would say that I want to get reference to the weather component because it supports live reload, right? So I will say that this is content and the type will be weather component like this. And it might be optional, of course. And somewhere, let's say in ng after view init, or sorry, content init, and let's say if content exists, I want to call the reload method for this component. And I will remove these things. And the problem is that we depend on the concrete content, weather content, when in fact we might have a lot of another different contents which are reloadable, which are supporting the polling mechanism and live reloading, right? So this is a violation of dependency inversion principle because we depend on concrete implementation rather than abstraction. So let's create this abstraction, and this abstraction will be represented in my case by injection token. So I can create the widget content token, and here I will export const reloadable content, and it's going to be new injection token which has value reloadable content, right? And the interface will be reloadable. So basically we say that the value for this injection token should implement this reloadable interface. So it should have the reload method and its loading property, right? And now we have to provide some assign some class to this token. And as we know, weather content, it is something which is implement this reloadable interface. So we will use dependency injection in order to provide this component instance as a value for our injection token. So we say that provide reloadable content and use existing weather content component. So once we try to get reference to the reloadable content, it will be resolved as an instance of this class, right? If you have some problems with understanding this, I have video which will pop up right there at the top, and there I explain in details this mechanism. Good, and now having this abstraction layer which is represented as a token, we can replace our concrete implementation with this token, and we can say here that the interface will be not the weather component content, but it will be something reloadable. right? So now we don't depend on the concrete widget content. We don't care what will be inside. We just care that this component or even directive should support this method and these properties. That's it. And if we save it and reload our page, we see that reload is happening called once for weather component because velocity doesn't support this feature, and this anything widget also doesn't support reloadable. So in our case, we have this widget component which is high level model, and it doesn't depend on the concrete implementation. It depends on the abstraction, and our concrete implementation also depends on the abstraction implementing this reloadable interface. And this is how dependency inversion looks in action. Alright guys, thank you for your attention. It was everything I wanted to tell you about solid principles in Angular. Don't forget that I have a couple of courses about Angular material theming and GraphQL engine called Hasura. In the video description you will find links to these courses and discounts which are currently active. Also, don't forget to subscribe to this channel, leave your feedback in the comments. As you can see, I listen to your feedback, and of course share this video if you find this useful. I wish you a productive week ahead, and thank you for your attention. See you in the future.